I am very excited to have you today here at the NLP for Healthcare Summit, together with my dear friend Abhi, to present to you how you can leverage the power of TigerGraph's high-speed graph processing engine, together with Spark NLP's state-of-the-art text processing, to gain deep insights and find connections deep hidden in your unstructured text data sets. My name is Christian Kasim Loan. I have been creating software for over 10 years and worked with various big data and AI laboratories. My passion lies in creating and architecting various cloud-agnostic big data and analytics systems. My most recent creation has been done together with the John Snow Labs, the NLP, the NLU library, which gives you all of the features of the Spark NLP library from John Snow Labs. But first of all, John Snow Labs is the leader in AI and healthcare, with various solutions in NLP, OCR, and providing various AI platforms, and has established itself as leader by acquiring various of the biggest companies in healthcare. And all of its features are available on most clouds and in most common languages. And now on to you, Abhi.
Great. Thank you very much, Christian. And, I hope everybody can see my screen right now. Now, let me take you to a little bit of introduction about myself. And this was Christian for you folks. I'm Abhishek Mehta. I'm Director of Field Engineering at TigerGraph. So I've been here at this conference because, I have done quite a decent work on the NLP side myself, and I've been, of course, a lifelong learner. I have a few patents in ontology domain, pattern mining, and of course, I've worked in the spaces of search engine and graph databases lately. A little bit of introduction about my product, TigerGraph. It's the company which I represent. This company is a native parallel graph with an MPP architecture. The company is founded in 2012 in Redwood City. Top 7 banks in the world have been using TigerGraph as their main strategy for graph analytics. We have raised $105 million in a Series C round in 2021. And our software is available on-prem, database as service, and AWS, GCP. It's a very cloud agnostic service. The biggest thing to learn about TigerGraph is that it's a graph database, and it's a distributed graph with ACID compliant that scales to terabyte of data sets. With that in mind, let me congratulate all of you for choosing natural language processing as your career path, because this is something which is very not only dear to my heart, but also has a great future. Let's look at some of the stats from the business perspective. Right, Gartner says that the BI intelligence is a 2020 market of $22.8 billion. And as per Reuters, this is something which is going to go into this like $30 billion. Now, if you just look at the font size, what the 4 times smaller is your graph analytics market, the text analytics market, which is around $5.5 billion, growing at 20% CAGR. But if you look in perspective, the cliche, what we all in the world of natural language processing have been saying from a long time, the 5 times bigger data set, the 80% of the business data is actually unstructured. So the scope where this text analytics, along with the graph databases, can take you is absolutely enormous. Either there has to be correction in the text analytics side going upwards, or BI intelligence scope has to be increased to have much more dollar amount coming into this domain. With that being said, doesn't matter what kind of world we come in from. You may be working for pharmacy benefit providers. You may be coming from a healthcare company, maybe a clinical research side, maybe creating a member's journey, 360-degree view. You are dealing with lots of data. Look at the data on this screen here for the member journey side itself, right? You have a healthcare record of this person, wellness check records. You got timelines when they have been missing their appointments and doing their appointments, their PII information. Or you are trying to deduce some kind of, what I would say, fraud detection based on the prescriber, how they have been taking to the claims guys and how they have been doing the claim processing or you are doing some biosciences comorbidity finding in terms of the genes or potential drug discovery based on familiar proteins, attaching them with the EMR data record, or anything on the clinical name entity recognition side. One thing which is key and extremely important to know here is that this is all interrelated data set, right? You have patient record, you got research experience, you got lab informatic information, social media data coming in, you got sales data, you got physicians information, highly interconnected set of data, but unfortunately it's siloed, right? The data is in various different formats. There are privacy issues, machine learning explainability issues, right? There is issue of the scales. So this is exactly what John Snow Lab and TigerGraph is trying to resolve together. So our combined solution is something what we call deep text analytics. It is combination of text analytics on top of the graph algorithm joined together with Spark NLP libraries. And that is what on the left-hand side, as you can see, John Snow Lab solution is being used to extract information, knowledge out of the data set, and TigerGraph data set is being utilized to connect the graph data sets for bringing in connectivity, taking care of the scale and speed of the information. And when this data set is joined together, we have deep link multi-hop analytics, which is taking care of pattern recognition, exposing hidden patterns inside your data set, performing deep text analytics at scale. So joining all of these together is something what we are going to demonstrate to you today. And now Christian is going to walk you through some of the capabilities of Spark NLP. And then I will come back and show you the demonstrations of the product. So what I'm going to do here, Christian, is I'm going to stop sharing and I'm going to pass it back to you for your part.
Yes, of course. Thank you very much for this wonderful introduction, Abhi, and really bringing close to us all the value that is in there in the text data world and in the graph world. And now what we need to learn first of all is how do you refine all this raw text data and get from this raw text data some highly structured, refined, and featureized data. Just like refining raw oil into pure oil, you need to make your text data clean. And then you can pass this clean data into the TigerGraph machine. But first of all, we need to understand the capabilities of Spark NLP. So Spark NLP is a big data text processing library, focusing on providing the most accurate, the fastest, and scalable models out there. And it has already accumulated millions of downloads in its few years after its release. And it focuses also on providing scientifically reproducible results, and it's establishing itself in the scientific community with various papers. And all this hard work has not only been awarded by making Spark NLP the most used NLP library in the industry and used by many trusted customers, but also this hard work has been awarded with various awards by the industry. And all of this is of course running on all the clouds in most of the common languages, and it has highly optimized builds for CPU and also GPU. And all of these features that Spark NLP provides work in over 200 languages. And if you compare the features provided by Spark NLP, which you see in this column, you really see why Spark NLP established itself as the most used one. You have all the common features like lemmatization, part of speech, and entity recognition, all at state of the art. And of course, some of the very useful features like spell checking or keyword extraction that no other library has to date. And so all of these features, for which are implemented by over 1,000 models and over 200 languages, are available in only one line of code in the NLU library. And it really puts an incredible amount of power at the tip of your fingers. Hundreds of classifier models for sentiment or translation and spell checking, and of course all the Bertology embeddings in just one line of code. On top of this, one of the most recent additions has been Google Five's T5 model. which enables you not only to solve any of the 20 tasks it was trained on, but some of the more interesting tasks it can do are things like text summarization, question answering, sentiment analysis, and many logical deduction tasks. Another very impressive model recently released is the Marian NLP model, which gives you the power to translate between over 200 pairs of languages. And with NLU, of course, in just one line. And of course, all of these state-of-the-art and latest birdology embeddings are supported, like BERT, Elmo, Albert, XLNet, and so on. One of the more interesting birdology embeddings are the so-called language agnostic BERT embeddings, which give you the power to train a model in only one start language. So you could say you train a sentiment classifier with only an English data set, but then by using the LabZ embeddings, it is able to understand and classify correctly in over 100 different languages. Like you can see here, it would be able to understand Zulu, Chinese, Greek, Spanish, and all the other languages, just by giving it the English train data and LabZ. And with NLU, of course, in just one line. And Spark NLP not only gives you all the standard open source embeddings, it has highly refined and trained embeddings from medical datasets, which enable Spark NLP to achieve state-of-the-art in all of the medical named entity recognition datasets and problem, or most of them. And of course, this enables the availability of all the very useful medical named entity recognizers, like pathology, anatomy, patient, and you can even extract sensitive patient data. And all of this, of course, is state-of-the-art by leveraging the incredible medical embeddings. And so now you could already pass all of these extracted named entities to TigerGraph. But Spark NLP provides various applications on top of the named entities. For example, for a given text string and an extracted disease, let's say I have cancer, you can extract if the string is saying the disease is present or conditional or absent. So the string I have cancer is present, but the patient might have cancer is conditional, or hypothetical is also possible. And so from all these entities that you have extracted, you can, of course, also map them to resolve common names. So because a medicine or disease might be referred to by various names in the text data, like thrombomastin sulfate, and you can map this to a common disease code. Or of course, you can extract the medicine in the named, the named entities that are medicine, and map these medicines to RX norm codes. And you, of course, have all of the other medical coding schemas, and we really support most of them. And of course, you can extract, we provide the incredible relation extraction, which lets you understand the relation between two entities. So given a date and some, let's say, treatment, you can understand if the treatment caused some problem, you can say, before or after, or if it happened at the same time, or if some treatment was cured after getting some treatment. And of course, you can also extract pathology entities and connect them to each other. So you can understand that a drug is prescribed at a certain frequency and has some strength. This all in combination with the de-identification algorithms, which basically let you identify which named entities belong or are data protected, and you can either mask them or even swap them out with fake data. So you can follow easily all data protection laws. And finally, on top of this, you can connect the world of PDFs and raw text data, like paper sheets, with Spark NLP, with the amazing Spark OCR library from John Snow Labs, which lets you apply amazing OCR algorithms on PDFs and map them straight to text documents, or even classify the PDFs and extract named entities straight from the PDF. And now that you know all the amazing tools that Spark NLP and John Snow Labs provides to turn your raw text data into highly featurized data, I will now show you the data set that we have aggregated for today to showcase you these features in an amazing demo with TigerGraph. So first of all, we collected 5.6 million tweets from Twitter, all talking about COVID. And these tweets are as raw and as dirty as it gets in the wilds of the real world. These tweets are full of dirty characters, spell errors, and different emojis. And so you will see now how you can leverage Spark NLP to clean all this raw and unusable data into highly featurized and structurized data, like turning raw oil into refined oil. And with this refined oil, we will power the amazing TigerGraph's analytics engine to generate deep insights. So what did we do with the data? First of all, we take the high-level bird's eye view of what we did. We had 5.4 million tweets and also 200,000 tweets, which are accompanied with the user profiles. And all these tweets are passed through some basic pre-processing and cleaning, like spell checking, normalizing, nemmatization, and stemming is what you could apply. And then afterwards, we extract from all the clean data the valuable features. This is where we pump the oil out and make it clean. So we extract unsupervised keywords extracted by the Yake algorithm, which gives you unlabeled keywords, leveraging statistical co-occurrence between n-grams. And then on top of that, we generate various contextual aware embeddings, and these are fed to the sentiment and emotional classifier, which gives us binary sentiment predictions, so happy or sad, and emotional predictions, which are 4 classes: happy, sad, anger, and surprise. And finally, on top of that, we also have the named entities. We have more general named entities like locations, companies, persons, and products, and also the disease entities, which we then, and also issues and pain and injuries, and we can resolve these to disease codes and injury codes. And finally, since this is Twitter, we of course have the hashtags. And so on a more low-level view, what did we do? We load all the data up to Databricks when we set up a Spark NLP cluster, and then we extracted the hashtags, raw and unprocessed. And then basically all of the text data, besides the hashtags, went right through the document assembler of Spark NLP, which is the gateway into the Spark NLP universe. So you have this data frame and put it in a document assembler, and it takes 2 paths. The tweet level operation path, where for every tweet we generate 1 contextualized word vector with the universal sentence encoder, which are then fed to the deep neural network architecture that is used to build the emotional classifier and a sentiment classifier, which then is saved into the sentiment and emotion tables. And then on the other path, we have the token level operations, which which are applied 1 token at a time, and they transform the token into a spell check version, a lemmatized and normalized version. And so all this clean data is then passed to the keyword extractor, and for the named entity recognizer, we have the general wordology, word embeddings, that general named entity recognizer uses, and the medical named entities embeddings, which we already mentioned, which give you the state-of-the-art accuracy together with the medical named entity recognizer. And all of this gives us the named entities. And these, on the one hand, we have the medical, the general named entities, and the medical named entities go through the entity resolver algorithm, and from that we get the disease codes. And all of this data gets passed through a JDBC connection provided by TigerGraph. And now Abhi will show you how you generate and see the real value with these amazing data set. So we just created the raw oil, and now we're gonna pump it into TigerGraph. On to you, Abhi.
Thank you, Christian. And I hope you can see my screen.
Not yet. Oh, no, it's loading. Wonderful. We can see you.
Wonderful. So, ladies and gentlemen, you are looking at TigerGraph Studio. It's a visual SDK. And of course, don't make up mind in terms of capability of this product. We got our RESTful APIs, connector frameworks, hundreds of other things. So I'm going to limit our demonstration today just as per the time set for this presentation. So what you're looking at is a Graph Studio, and as Christian was explaining you, what has been extracted out of the NLP libraries has been pushed into TigerGraph directly, and this is how a graph schema looks like. You got a tweet, as you can see, just like your RDBMS table. It has all these attributes. The tweet has more semantic relationship because it's a node, and this line between the tweet is called, between the other tweet and hashtag is called an edge, right? That's the semantic relationship. The tweet has tags, and tag has its own attribute. Tweet is by a user. A user has a profile. Profile has a location. Tweet can have a location, and also tweet can have named entities and diseases. And as you can see on the tweet, you have sentiment, confidence, and emotion. To the first time graph viewers, it may look like this is just turning the rectangles into circles. So what is the difference between any other data store? I will walk you through that process very soon, but just make up your, just see that this is a totally different way of storing your data. This is more of a data-centric view where it's more like a pointer system where each node has an urgency matrix, and it knows what other node is connected to it just one hop away. So what I'm going to do, the next stage is going to be the map data, right? We have mapped this data from external sources. As Christian was telling you, this is coming from JDBC driver. Here is the mapping. We have some sample CSV files over here telling the system that this column from this hashtag has to be lowercase, trimmed, and then put it in a particular kind of node. So this whole mapping with this ETL exercise takes place over here, and this is what we call a loading job inside TigerGraph. This can be scripted, this can be triggered through APIs. But right here, what I'm showing you is just a visual component. And the next stage is loading of the data. As you can see, the data is loaded. It's a 32 gigabyte system with probably 16 cores, has 11 million vertices, 54 million edges. We're talking about 4 million tweets almost inside this system. So it's a fairly okay system kind of detail. Just for a minute, let me take you through what is the difference between a graph database and and RDBMS. Let's look at it very quickly. So I'm going to look at a tweet which is stored in a system. And as I double click on it, you are going to see one hop away from this tweet are all its hashtags, all the locations, all the named entities which has been extracted out of tweet. And this is a data centric view, right? I mean, what you're seeing is that your data one hop away connects with everything else what is possible as per the schema. So let's go into this path a little bit more. So this user should have many tweets and other details. See, this user has other tweets, and these tweets are coming from, there is a retweet from another user over here. So this is not about visualization, folks. What you are looking here is the interconnectivity of data set, which is getting exposed automatically just by the nature of the graph. Christian didn't send me data in such a way, right? Means he just pushed the data in, and as the data was getting stored inside the graph, we figured this out, that this user has tweets, tweets has hashtag, hashtag has other tweets have other user associated with it. So this whole pattern was automatically deducted by graph, and the simple value of this thing, one you should look at, is the inbuilt graph algorithm. What does that mean? Is that can I ask the shortest distance between these two users and say how are they all interconnected? Right? You don't have to tell the system what path to follow. The system, the TigerGraph can go in and, sorry, let me see. And TigerGraph can go in and just retrieve this path for you. It's going to say, okay, find me the shortest path. Here we go. I'm just going to remove everything and find a path. And here goes the system finding the path that via a couple of tweets, this guy is correlated because there was a retweet done by the user. So this is the value of interlinkages between a graph database, and that is what we are going to use to drive higher level analytics. Let me quickly walk you through that. Let me ask this system for more than million hashtag, what are the top hashtag in the system, right? We are counting the hashtags, we are sorting them, and then we are delivering it to screen without any caching over millions of record. And its system tells me that there are more than 200,000 or so much of COVID-19 tags. Now, of course, because of the NLP world, people like you and me would think that, guys, there is synonyms over here. Yes, we can resolve and we can do word sense disambiguation. But now this is not the purpose of my exercise today. I'm going to go in and ask the system for this hashtag. For this hashtag, can you tell me, sorry, not the location, for this hashtag, can you tell me what are the emotions running around today for these dates which I mentioned? And system goes, calculate on those hashtags the tweets, summate all these emotions, and give the percentage to you in matter of milliseconds. And it says there is a fear of 77% and there is a joy of 2%. Oh, really? There is a joy. So how about we add COVID vaccine in it? And as soon as you do that, recalculate, and as you can see, the fear went down of overall. And okay, I misspelled it. And you can see the fear went down when the COVID vaccine start coming in. And this way you can do much more smarter, much more deeper analytics, do break it down onto day-by-day basis, bring a time series angle, go as much deep as you want. I'm just running 2 hop-down queries to show you the value and the speed with what you can use this system. You can, once you are in graph database, you can go inside. Once your structure is graph, you can do much more than just simple application and exercises of computations and aggregations. You can run graph algorithms to do deep link analytics. The example which I showed you right now, you can detect auto patterns. That is there a pattern that once somebody tweets it, what's the influential mark on this person, that when he tweets it, everybody else also pushes the hashtag up? What about the community detection, that how are COVID-19 tweets related with some comorbidities in some specific diseases? And also hub in community detection when page ranking algorithms, which can all go top of this and can create huge value for your overall system. Now, of course, the idea here is not to run it on a toy problem of tweet. The idea here is to solve the real world problems. And that is where, if you remember the use cases I was talking to you earlier about, biosciences use case, finding comorbidities, member journey, customer 360 use cases, finding fraud, clinical name entity recognition, and joining the various diverse data sets together. That is where the value of graph database comes in, that now you have a distributed graph like TigerGraph behind the scene of your NLP engines. Rather than just telling us what is the capital of United States, you can actually go in and ask much more deeper business-ended questions and get the answers on top of it. Right? Means what is the impact of COVID-19 in these cities in the United States with following hashtags. So much more deeper analysis you can do. Now, I know this has been a very quick walkthrough, folks. We had a limited time today. We have another upcoming event coming from TigerGraph side. It's a TigerGraph AI Summit. And there again, Christian and I are presenting the same use case in much more technical capacity, much more capacity. You would see many other companies talking from JP Morgan Chase, JLR, Forrester Research. So I would welcome you to please join in. It's free event to join. And there is a separate NLP track over there, which would be very useful for you. And we will touch base again on this topic in much more technical sense. With that, I want to thank you, all of you, for joining us today. And back to you, Christian.
Yeah, thank you guys, everybody. So I also want to thank you guys for visiting the NLP Healthcare Summit and honoring us with your attention. I want to encourage you guys to check out TigerGraph's graph analytics engine and NLP's text processing engine. Spark, John Snow Labs Spark NLP text processing engine. So thank you guys very much and see you in the next summit.
Take care.
Bye-bye.